Alright, so now let's look at example 1-2 and 1-3. Okay, so first with 1-2. So you have a object. An object with volume 0.3 meter cube, right? And it's fully submerged in the water. And we know that the density of the water is given as 1000. Okay, and the question is, what is the buoyancy force and what is the density of the object? So the situation is this: it is already fully submerged, but your forces remain the same, two forces over here. So I can say that it is W equals to FB. Weight is the mass of the object multiplied by G. Okay. Buoyancy force is the mass of the displaced water multiplied by G. So I can cancel away G. I'm left with these two. Mass of the object is volume of the object times density of the object. Okay, and what about the volume of the displaced fluid times density of water? Since the whole fluid displaced is the same as the volume of the body, this is actually equals to this. Okay, the whole thing is submerged. So actually your density of the object is the same as density of water. Okay, and the buoyancy force is basically your mg. Buoyancy force, yeah. So you will have 0.3 volume times density of water times 9.81. Okay. And you get 2943 newtons. So this is question example 1-2. Example 1-3. It's about an iceberg. So it is floating and it is a cube. Okay, cube meaning that it is the same length on all sides. So it is floating. 5 meters here, so this is 45 meters here. Okay, the other two dimensions are 50 by 50. Alright, and what is the buoyant force and what is the density? Same question here. W equals to buoyant force. This is mg of ice and mass of displaced seawater multiplied by G. So the mass of the ice is the whole volume, 50 by 50 by 50 times density of ice times 9.81 is equals to the displaced volume is 50 by 50 by 45 times density of seawater times 9.81. Alright, so you realize that I can actually cancel out quite a number of terms and I'm left with this 4. So the density of ice over density of seawater is 45 over 50. Okay, it is 90% the density of seawater. 0.9 times density of seawater. 1025. 922.5 kilogram per meter cube. Okay, so my buoyancy force is just 922.5 times 50 cube times 9.81. Okay, very big number. 1, 2, 3. 1.131 kilo Newton, meganewton, giga. Wow, times that. Okay. 1.131 times 10 to the power 9 newtons. Alright. So that's question 1, example 1-3.